Hello students, welcome to the class. Today is the second class of our optics Entrace special. So in this second class we will be discussing, in the last class we have already seen that shadow formation which is generally not touched, and we will discuss today some further details. I would like to discuss with you people the portion which is generally not discussed with in the general discussion, because question can be from any part of your syllabus which you have read from your childhood. It is not essential that what is mentioned and that you have read in your childhood that will not be asked. So any type of question can be framed within your syllabus. So we will be discussing, my main intention will be to touch those parts of the syllabus which has applied meaning and that is in the hidden form present in your syllabus. So what I would like to tell you, second class of optics. Now the main thing I would like to tell you that we have to start the reflection. In the process of reflection, you all have the basic idea that what is I, what is R and all these things. So I will not be discussing those matters. Simply with that introduction, here what I mean to say that if this is a plane mirror, this is incident ray, this is reflected ray, and this is normal, then you already know I is equals to R, angle I is equals to angle R, and incident ray, reflected ray and normal lie in the same plane. What does it mean by same plane? Try to understand. Same plane means if this is the incident ray, this is the reflected ray, this should be the normal, not this should be the normal. Always you will have to keep this thing in mind that normal should be on the reflecting surface and incident ray, reflected ray, normal should lie in the same plane. Mathematically, if in terms of vector, if you will write, if this is reflected ray, this is normal, I cross n vector dot R vector should be equals to 0. This is the meaning of second law of reflection, that is incident ray, reflected ray and normal should lie in the same plane. What does it mean? I cross n is a vector perpendicular to I and n, and as R is also in the same plane, so it is perpendicular to R also. So ultimately cos 90 is 0. So this is the vectorial meaning of the three incident ray, reflected ray and normal that lie in the same plane. If they are represented by vectors along the vectors, then this should be 0. This is called box product. Box product. So box product should be 0. This is the meaning of your incident ray, reflected ray and normal lie in the same plane. If you cannot see here, this is the incident ray, this is the reflected ray, though this is normal, but this cannot be normal because it is not in the same plane. It should be the normal because it is in the same plane. They all should lie in the same plane. So in this way you have to keep in mind. It should not be in this way, that two vectors are there and suppose this is your normal. It cannot be there because this is incident ray, this is reflected ray, they are in same plane and normal is not in this. So normal is always on the incident surface, it is normal in this way. Now next thing what I would like to tell you, I would like to discuss with you the vector form, that how can we represent it in vector form. In vector form, basically, if suppose the question is given in this way, that this is a vector along incident ray, this is the vector along normal, you have to find the reflected ray vector as a function of incident ray and normal. That means how, if incident ray and normal is given, how you can find the reflected ray. This is the main thing I would like to discuss with you. So see, for this I am taking the incident ray along this vector, the reflected ray along this vector, and the normal along this vector, and this is our reflecting surface. I am taking this vector as the t vector. Now, if I analyze here, this is the normal direction. If I take this reflected ray, this angle is theta, this angle is theta, then अलिकति भेक्टरको ज्ञान हुनै पर्छ, राम्रोसित ज्ञान हुनै पर्छ भेक्टरको राम्रोसित ज्ञान नभएपछि you cannot understand this thing. So carefully see the vectors also, revise vectors and then see this discussion. मैले के भने, if we take this r vector is equals to यो vector को यो component, that is n cos theta, and यो vector यो theta भयो तो यो 90 minus theta भयो, यो के भइहाल्छ t plus t cos 90 minus theta. So it is your t sin theta plus n cos theta. This is r vector that we have got. Now if we proceed in this direction, I incident ray and normal in this direction, then see, this is your, this angle is again theta, vertically opposite. So this is minus n. So what we can write, this is I vector. So we can take I is equals to I vector is equals to minus n cos theta, यो minus n, यो plus n को direction भयो, यो minus n. So this is minus n cos theta, and this is 90. So this is t cos 90 minus theta, because this is 90 minus theta. This angle is 90 minus theta. This is 90 minus theta. This is also 90 minus theta. So what we are getting? We are getting t sin theta minus n cos theta. This is equation number 1. This is equation number 2. Now what you do? You subtract these two. So this is I. This is I. So if we will subtract, what we are getting? This is minus, and this is plus. So r vector minus I vector should be equals to 2n cos theta. So r vector should be equals to I vector plus 2n cos theta. What was my question? My question was in terms of I and n only. So this theta is also an additional. Now I would like to get the value of theta. To get the value of theta, take it as equation number 3. Take it as equation number 3. So if we want to get the theta, I vector dot n vector is equals to I को magnitude 1 n को magnitude unit vector cha 1. Now what is the angle between these two vectors? This thing has to be understood. This is not the angle. Now you see, the angle between the vectors is this is theta, and this is 180 minus theta. So angle between the vectors is the angle between the tails. So this is not the theta, this theta should be there. So cos 180 minus theta, that is I dot n is equals to minus cos theta. So we have got minus cos theta. So from 3 what we can get? From 3 we get r vector, that is vector along reflected ray, that should be equals to I to cos theta I dot n into n cap. This is the result that you are supposed to remember all the time. This is the result that you are supposed to remember all the time, that reflected vector, incident vector 2 into I dot n, n cap. So this relation should be always understood by you people regarding the law of reflection in the vector form. This is giving you the law of reflection in the vector form. We will try to understand this thing by some example also. So let us try to see it with the help of an example. Now, how simply you can understand the example that you try to understand. Suppose a vector, incident ray vector is along, incident ray unit vector is given 1 by root 3 I cap plus 1 by root 3 j cap plus 1 by root 3 k cap. Incident ray vector is there, and surface is in yz plane. This is not a meaningless statement. This has got a very deep rooted meaning, and you have to find the reflected ray. Reflected ray vector is how much? Which unit vector will represent the reflected ray? Now here you have to understand very carefully. I will apply the same concept. Here you have to understand first the normal. Now you see, yz plane is there. When the incident surface is yz plane, that is normal is towards x axis. So therefore normal is your I vector. This is your normal. So normal is your I vector. This is your normal. Now you apply. R vector should be I vector. I vector is what? 1 by root 3 I plus 1 by root 3 j plus 1 by root 3 k I plus 2 into I dot n. Now I dot n, these two terms will be 0. These two terms will be 0. I dot n, these two terms will be 0. J dot I and k dot I 0 and I dot I 0. So 2 into 1 by root 3 I. This is here. So here I have done some mistake. Calculational mistake is there. Here it should be minus. Check it. This check, it should be minus. Negative sign should be there. So here it should be minus, and then we are getting minus 1 by root 3 I plus 1 by root 3 j plus 1 by root 3 k. This is the thing that we are getting. So what I mean to say here, in general I would like to tell you that in general, any vector, if incident vector is along xi plus yj plus zk, xi plus yj plus zk, and it is in xy plane, reflecting surface is in xy plane, then you will get reflected vector as this component should be reversed, perpendicular component should be reversed, xi plus yj minus zk. This is your reflected vector, and that is from this relation only, I minus 2i dot n cap. So this is the your law of reflection in vector form. So we have seen that if the incident vector is along I, then reflected vector will be given by this result, and we have seen this one. Now the same question I am trying to give you, the same application, vector application. I would like to tell you that suppose this is the reflecting surface. Second example I am giving you. This is the incident ray, I by 2 minus root 3 by 2j. Incident ray is along this vector. This is incident ray, is not this vector. Incident ray is along this vector, and reflected ray is along this vector. Now the question they are asking, what is the value of theta? Theta is equals to how much? This is the question, that what is the value of theta. Now in this question, you all have the idea that this is based on dot product. This is the incident ray along this vector, reflected ray along this vector. Now what is the value of theta? In order to understand this problem, you must have a sound knowledge of dot product. Now see, if I take this vector as A and this vector as B, then A dot B vector is equals to A vector magnitude, B vector magnitude cos theta. But here the mistake that a student does, the angle between the vectors is not this theta. In fact, this angle should be the angle between the vectors. So it should not be theta, it should be, suppose I am taking this angle as alpha, then it should be cos alpha. This angle should be, because angle between the vectors is the angle between the tails, and we can find the value of alpha. So cos alpha is equals to how much? Cos alpha is equals to vector A. What is vector A magnitude? 1 by 4 plus 3 by 4 under root A I plus B j vector has magnitude is equals to A square plus B square under root. So this is the formula I am using. So if I take this way, then B vector is how much? B vector is into B vector is B magnitude, same 1 by 4 plus 3 by 4 under root by cos alpha A dot B. A dot B is how much? I by 2 minus root 3 by 2 j dot I by 2 plus root 3 by 2 j. This vector. Now this is what? This is 1. So what we are getting? We are getting cos alpha is equals to, I have done mistake. This should be in numerator and this should be in denominator. So better I should write in this way. This should be in denominator A magnitude B and this should be in numerator. So I should write I dot I 1 by 2 and j dot j minus 3 by 2 by 1. So what we are getting? We are getting minus 1 by 2. We are getting minus 1 by 2 and that is equals to cos 120 degree. So alpha is equals to 120 degree. Here see, here this should be in lower side, this should be in upper side. So we are getting alpha is equals to 120 degree. If we are getting alpha, it is not our answer. Answer is your alpha plus this angle is theta, this angle is theta, alpha plus 2 theta is equals to 180 degree. So 2 theta is equals to 180 minus 120 degree, that means theta is equals to 60 by 2, that is 30 degree. So your choice will be 30 degree, 60 degree, 120 degree, 90 degree, and this should be your right choice. So this type of vector application can also be applied in the discussion of ray optics. So this should be clearly understood in your mind. Now we are talking about reflection. From the childhood, you know there is a regular reflection and diffuse reflection. So regular reflection, if a smooth surface is there and ray of light is coming in this way, it is going in this way, then this is your regular reflection, and intensity is not same throughout. So image is formed. Whereas if we take the diffuse reflection, suppose this type of, so here you will observe that so what I mean to say, that in diffuse reflection the pattern of incoming ray, incident ray, is not the pattern of reflected ray. So you will see that everywhere the intensity will be there. So it has also got the use, and therefore due to diffuse reflection only, if an object is there in the room, from every side you can see the object with same intensity. So this thing should be understood in mind. Here the intensity is uniformly distributed. Intensity is uniformly distributed in all directions. So we are able to see an object in a room from all sides with same illumination due to diffuse reflection. This is diffuse reflection. On paper we are not able to get, and due to regular reflection image is formed. So in plane mirror the image is formed, whereas in case of paper we are not able to get our image because there it is diffuse reflection. So this thing also should be clearly understood about regular and diffuse reflection. Now a very important concept is there, normal incidence and grazing incidence. Normal incidence, grazing incidence. In normal incidence, if this is the reflecting surface, ray will come and it will retrace its path, retrace. Whereas in grazing incidence, if I am taking, this is the way the ray is going, this is incident ray, this is reflected ray, this is incident ray and this is reflected ray. This has got a wide variety of use in your discussion of reflections. For example I am taking, here is two plane mirrors and a ray is incident parallel to the mirror M2. Ray is incident parallel to the mirror M2. The angle between the mirrors is theta, and you have to tell the value of theta. Theta is equals to question mark if after two reflection ray retraces its path. Or the question can be after three reflections ray retraces its path, or after suppose 10 reflections light ray retraces its path. In this situation, one question is this, one question is this, and one question is this. It may be 10, 12, 10, 12, 9, 7, whatever is the value. Now see, for retraces the path, for this retrace the light should fall normally. I should be equals to 0 degree for retracing. Now one reflection has taken place here and second reflection will be normal. If it is normal, the ray of light will retrace its path. So if we see this is parallel, so this is theta. Here we know normal 90 minus theta, 90 minus theta, so this is theta. This is 90 degree and we are getting 2 theta plus 90, 180 degree. So theta is equals to 90 by 2, that is 45 degree. This is the first case. This answer is 45 degree. Very good. Now in second case, if we want 3 reflections, after 3 reflections, this is the thing, 3 reflections ray retraces its path. How to get it? So in the case of 3 reflection, what we have observed, that here is the first reflection, here is the second reflection, here is the third reflection. So This is the incident ray. It is retracing its paths because it is falling in normally and then it is going into this path. This angle is theta, so this angle is also theta. This is 90 minus theta, this is 90 minus theta, so this angle is again theta because this is normal. Now if I take this angle as x, then this x plus 90 plus theta, 90 plus 2x plus theta is equals to 180 degree. That means 2x plus theta is equals to 90 degree. That means x is equals to 90 minus theta by 2. If we come into this triangle, in this triangle, then theta plus this 90 plus this angle is your 90 minus x. 90 minus x plus 90 plus theta is equals to 180 degree. 90 minus, at the place of x I am writing 90 minus theta by 2, 90 minus theta by 2 plus 90 plus theta is equals to 180 degree. And so minus 45 plus theta by 2 plus theta is equals to 0. So we are getting 3 theta is equals to 90, so theta is equals to 30 degree. So what I mean to say here, that in 2 reflection we have got theta is equals to 45 degree. In 3 reflection we have got theta is equals to 30 degree. This process can be continued, that we can say theta is equals to pi by 2n. Pi by 2n. Why? Where n represents number of reflections. Here you see, if 2 reflections are there, then it is your 180 by 4, and 180 by 4 is how much? 180 by 4, that is your 45 degree. We have got this as the answer, 2 reflection. If n is equals to 3, we are getting 180 by 6, that is your 30 degree. Similarly, you can continue this. So this formula is important. You have to remember this formula, that this formula has to be understood very carefully, that theta is equals to the angle between the mirrors is pi 180 degree by 2n, where n represents the number of reflections. So I hope that with this amount of undiscussed questions, generally these questions are not discussed in your +2 classes, and this question will help you in getting your solution to the problem as far as possible. So in the next class I will be discussing few more things.